Hello and welcome to MakeLearn 360. In this video, I want to solve some couple of problems to illustrate the concept of the first moments of area as well as the centroid. Okay, now let's solve this problem together. Okay, so it says that if the cross-sectional area of the beam is 8,400 millimeters square and the y-coordinate of the centroid of the area is 90 millimeters. What are the dimensions D and H? All right, so that is the problem. Now let's look at the problem. The first thing to do is to divide our cross-sectional area into um, regular shapes. So you can clearly see that our cross-sectional area consists of um, some rectangles. Okay, so let's divide these rectangles into two parts. So I can draw a line here, and if I draw a line over there, I can see that, let's say this is area 1, and then all over here, let's call it area 2. All right, okay, so having done this, we can clearly see that what is area 1. So area 1 is going to be 200 multiplied by h. That is the area 1. Okay, and then area 2, which is the second area, since it's a rectangle, again is going to be 120 multiplied by b. Therefore, we can say that the total area, which is a1 plus a2, is nothing but what? 200h. All right, so maybe in terms of alphabetical order, I can say 120b plus 200h. All right, now this 120b plus 200h should be equal to the total area, right? That is the cross-sectional area. So we can call this sum equation 1. All right, let's call this equation 1. All right, now let's look at the next parameter. He said that the y bar is 90 millimeters. What is the y bar for this area? But the y bar is going to be summation ai, so summation ai y bar I divided by summation ai. That gives us the y bar. So we are going to do summation ai y bar I. In other words, a1 y bar 1 plus a2 y bar 2 divided by a1 plus a2. Now if we do this, what can we see? All right, so what are we going to do? So we are going to say that y bar is summation ai y bar I divided by summation ai. So let's start from y bar 1. So to locate y bar 1, we need to come this way, and y bar 1 is, so this is area 1. So y bar 1 is from the origin all the way to halfway over here. But we know that this distance is 120. So I will add 120 to halfway of this distance, right? Which is h over 2. So it means that my y bar 1 is going to be 120 plus h over 2. Simplifying this further, I can rewrite this as 2 multiplied by 120 divided by 2 plus h over 2. So that I can finally write this as y bar 1 is what? 2 into 120. So 2 into 120 is 240 plus h over 2. That is my y bar 1. Again, to calculate my y bar 2, so y bar 2 is actually that distance all the way, so this is area 2, right? So all the way to halfway here from the origin, that is going to be half of 120, which is what? Half of 120, 120 half, and I think that is going to be 60 millimeters. We don't need to calculate this. Now we are done. Now we are saying that the y bar is going to be a1 y bar 1 plus a2 y bar 2 divided by a1 plus a2, which is the total area. So basically, we are trying to say that A1, so A1 is 200 multiplied by H. So it's going to be 200 H. Then I'll multiply by Y bar 1, which is what? The Y bar 1 is 240 plus H divided by 2 and plus A2. Now what is A2? So A2 is what? 120B, and then Y bar 2 is what? 60. So we are saying that if I divide this by the total area, um, the total area is what? 8400, which is A1 plus A2. Don't forget that the total area is um, 8,400, right? Okay. So now having gotten to this part, um, what can we say? We are saying that, so basically we are saying that this is 90. 90, so we are saying that this Y bar value is 90, okay? So 90 multiplied by 8400 will be equal to 200. So this 2 will take off this 100. So it's going to be 100 multiplied by 240 plus H, and then plus 120 multiplied by 60 multiplied by B. All right. Now at this juncture, we have equation in terms of H. So we need to substitute maybe H or B. Now making B the subject of this equation, the first equation from the area, you can say that B is what? 8,400 minus 200H divided by 120. So then I can substitute this and say that 90 into 8400, 100 into 240, small of that is 100H plus H plus 120 multiplied by 60, and the whole of B, which is what? 8400 minus 200H. So 8400 minus 200H, all divided by 120. Now, if I do this, then I have 90 multiplied by 8400, which is 756,000 to be equal to 100 multiplied by 240. What is it? 200 multiplied by 240. So that's going to be 24,000 H. Okay, so 24,000 H plus 100 H squared, right? Okay. Now plus 120 over here. We take off 120. Then I'll multiply 60 by 60 by 8400, 50400, so 50400 to 000. Okay, minus 60 into 200 H, so 60 into 200, 12,000, so 12,000 H. All right, so I have 12,000 H. Now, okay, so at this juncture, let's solve this quadratic equation. So 100 squared, then 24,000 minus 12,000 H, that's going to be so 24,000 minus 12,000 H. So that is 12,000. So plus 12,000 H, and then um, yeah, so I'm going to have 5400, then I'll subtract it. So 504000 minus 756000, right? which is minus 252,000 to be equal to 0. Now we can solve this quadratic equation to get the value of h. Then the value of h that we get, we come back and substitute into b to get the value of b. So there is a simple way to do this with a calculator. So you come to mode, you come to 5, which is equations, then you come to 3, which is quadratic. Okay. So 100, 12,000, yeah, 12,000 minus 252,000. Okay. So my h is 18.23 millimeters, or my h uh, minus 138.23. But we cannot measure dimension and get um, negative, right? We cannot measure dimension and get negative. So the negative value, we are going to ignore it. So basically, our h is 18.23 meters. That is the correct answer. Now, since h is 18.23, and to solve for b, we will just put h equals 18.23 in this equation. So we can say that b is going to be 8400 minus 200 h, which is 18.23, all divided by 120. Now, if I do this, so let me clear. So it's going to be 8400 minus 200 multiplied by 18.23 divided by 120. So what is that? So 39.62. Okay. So 39.62 millimeters. So H is 18.23, B is 39.62 millimeters. All right. So this problem has been solved. Okay, let's look at the next problem. All right, so let's look at this problem. All right, so we've been asked to find the centroid of this figure, x bar and y bar. Okay, so let's start. What do you see? So we can assume that this whole figure is actually a rectangle, which we have taken two semicircles out of it. So that is the best way to look at this. The whole of this figure is a rectangle, and I have taken a portion or two portions of you know semicircles out of it. All right. So let's start the analysis from our rectangle. Now, what is the x bar of our rectangle? Before I talk about this, let's look at this carefully. So whenever you are finding the centroid of areas and one of the axes divide the areas into exactly two, then okay, so this is what we are saying. The first moment of area about the x is y bar a, and then the first moment of area about the y is x bar a. And so whenever you have um, an axis which is passing through, for instance, for this problem, the y-axis divides the area exactly into equal halves. For such a problem, then what happens is that since the x-axis divides the area into two equal halves, then we say that the first moment of area about the x-axis is actually 0, because there is no moment about the x-axis. In other words, the x-axis divide the area into exactly equal halves. For that matter, if you have problems like that, then we say qx is actually 0. Okay, and then if qx is 0, y bar so y bar will be 0. Okay, so to summarize everything, whenever the x-axis divide the area into exactly equal halves, y bar is 0. And whenever the y-axis divide the area into two equal halves, then x bar will be 0. So for this problem, the y bar is actually 0. Okay. the y bar is actually 0. Okay. What this is, you know, what this what this means intuitively is that you cannot stand on the origin and walk along the y to get the center. That is what it means, because the y-axis is already at the center, so we cannot walk and get to the center along the y-axis. That is what it means. Okay, so starting from the rectangle, the x bar is starting from the origin and walking to you get to halfway of the rectangle. So you know this is 200. So halfway of 200 is what? 1/2 of 200, which is what? 100, isn't it? So for the rectangle, the x bar is what? 100 mm. Okay. Now, um, the y bar is going to be. Oh, sorry, we said the y bar is 0. Yeah. So we don't need to bother about it. But let's calculate the area. So the area of this rectangle is going to be length, which is 200, multiplied by breadth, or height, or whatever you want to call it, which is 140 plus 140. So 200 multiplied by 140 plus 140. And when I do this, what am I going to get? So when I do this, I'm going to get 200 plus 140 plus 140, which is 480, right? So I'm going to get 480 millimeters squared. And that is actually the area of the, oh, sorry, it's 200 multiplied, not added. So 5600, oh, I'm back. 5600, in fact, the zeros are 3 millimeters squared. So that is the area, right? That is the area over here. And now we are done with the rectangle. So let's look at the semicircle. Let's look at the bigger semicircle. So 1, let me call this 1, and let me call this 2. So semicircle. So looking at this bigger semicircle, what can we say? You can see that for the x bar, okay, so the x bar is like walking from the origin along this distance to locate the center. Let's call it some c. For a semicircle, that distance is given by a formula which is 4r divided by 3 pi. So whenever you have a semicircle, then the center coordinate from the base can either be horizontal or vertical, but this one, the base is vertical. So we are saying that that distance to locate the center is at a certain distance from the base, which is given by 4 multiplied by the radius divided by 3 pi. So it's actually 4 multiplied by the radius, and for this one, um, the radius is what? Is 100. So 4 multiplied by 100 divided by 3 pi. And if you do this, you are going to get the x bar, that is the distance from the origin to where the center is, or the centroid. So it's going to be what? 4 multiplied by 100 divided by 3 multiplied by pi. So that is 42.44. Okay, 42.44 millimeters. Now we don't need to calculate y bar because y bar is already 0. Why is y bar 0? Because the x-axis passes through the centroid, right? Um, so we can see that it's actually 0. Okay, so let's calculate the area. Now it is very important to know that whenever you are calculating the area, or you are dealing with centroid and you are calculating the area, and then it is a hole, then it's actually a negative area, because it is assumed that I had, so this is assumed that initially I had a rectangle, then I took an area away. All right. So to represent that area I took away, then it's going to be negative. But what is the actual area? In fact, the area is going to be half pi r squared, right? That is half of the area of what? A circle. That is because it's a semicircle. So half times pi times 100 squared, right? And that is going to give me what? So that is going to be 1 half multiplied by pi multiplied by 100 squared. So 1 and 2 multiplied by pi 100 squared. So 15707.963 minus 15707.963. Okay, so millimeter square. The minus sign is because we are assuming that it's actually a hole. All right, so now we have our area, we have our y bar, and then we have our x bar. Okay, so now let's take the last one, which is the this semicircle. All right, so for that semicircle, so semicircle 2. So for semicircle 2, we are going to get this. We are going to say that the base, so for this one, the base is here. And then the distance that we need, so the centroid, let me put it this way, the center coordinate along the x for this semicircle is going to be this distance, which is what? 4 times the radius. So we are going to use the same distance again, 4r over 3 pi. But that is not the s bar. The s bar is the distance from the origin, so you get to the center. So in other words, the whole of this distance is 200. But we know that this distance from here, from the base to this point, is 4r over 3 pi. So if I want to get the actual x bar, which is the distance from the origin to I get to the center, then it will be what? 200 minus what? 4r over 3 pi, which is what? 4 times what? The radius in this case is 50. So it's going to be 200 minus 4 times 50 divided by 3 pi. I hope the concept is clear. And what is this going to give us? So we are going to get 200 minus 4 multiplied by 50. Then I'll divide by 3 pi. 178.78. 178.78 millimeters. So that is the x bar for you. Now again, the y bar is going to be, so for the y bar, oh, that is also 0. We don't need to worry our head. So the area, okay, the area again is going to be negative because it is also a hole, but it's what? Pi r squared. The radius is 50, so we are going to get the area as what? So the area is going to be 1 half of pi multiplied by 50 squared. So what is that? So 3926.99. 3926.99 millimeter squared. So that is the area. Then, so that is what I have right here. Now, at this juncture, I have been able to get x bar. For the y bar, we know it's obviously 0. So no doubt about that. But we know we have our x bar, and then we have our various areas. All right. All right. So we are good to go. But we have to represent every information we have here in a table. Let's do that. All right. So there we are with our area, our table actually. So we have to put every value we have into our table. Let's start from area 1. So area 1 is the rectangle. What did we get for the area 1? We had 56000. So the unit over here is in millimeter square. Right? And this one is millimeter. This one is in millimeter cube. And then this one is also in millimeter. Then this one is also in millimeter cube. So 56000. Okay. What is x bar? X bar is 100, isn't it? X bar is 100. So 100. For y bar, it is actually 0. You don't need to bother about it. Now, the second area, which was the semicircle, the first semicircle, S bar is what? 42.44. So 42.44. But what is the area? Minus 15707.963. Minus 15707.963. Y bar is 0. And finally, for the second semicircle or the third area, our area is actually minus 3926.99, and then this one is 178.78, but the y bar is 0. Let me write this well. Okay, so we are going to complete the table by multiplying AI x bar I. This one is going to be AI y bar I, but it's going to be 0 because we realize that everything y bar is 0. Okay, so we just have to fill this column. Starting from the first one, 56000 multiplied by 100, that is what? 56, how many zeros? 1, 2, 3, 4, 5. So 5 zeros. So I can also say that uh, 5, 6, 1, 2, 3, 4, 5. Okay, all right. Millimeter cube. And then what is the second one going to be? So minus 15707.963 multiplied by 42.44. What is it? Wow. So we are getting 6, 6, 6. How many of the 6? 1, 2, 3, 4. So 1, 2, 3, 4. Point, 4, 5. Point what? 9, 4, 9, 7. So let's say 9, 5. Okay. And then finally, let's look at the last one, which is going to be minus 3926.99 multiplied by 178.78. So minus 702067.27. So minus 702067.27, right? 0.27. Okay, so at this juncture, I think we are good to go. So we are just going to sum AI. So let's sum AI. What are we going to get? We are going to get 56,000 minus 15707.963 minus 3926.99. That gives me 36365.0. So 363 65.047 millimeters squared. So that is the total area. So 363 65.047. Now let's do summation AI S bar I. We are going to add this column. So it's going to be 5, 6, how many zeros? 1, 2, 3, 4, 5 zeros. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Okay. So you have to be very careful. Minus 1, 2, 3, 4. The 6 is 4. So 1, 2, 3, 4. 4, 5.95. And then minus 7, 0, 2, 0, 6, 7 to 702067.27, right? And this is going to give me 4231286. So 423 423 1286.78 millimeter cube. Is that not it? So I have summation AI, then I have summation AI S bar I. So I can go ahead and calculate the S bar. So the S bar is going to be summation AI S bar I divided by summation AI, which is what? 4231286.78 divided by 36365.047. And what is the S bar? The S bar is going to be 4231286.78 divided by 36365.047. And this is going to give us 116.40. 116.40 millimeters. So interestingly, what this is telling us is that the center of the whole of this is somewhere around 116.4. So you know the origin is already here. So a distance. So we are saying that our centroid is at a distance 11, 116.4 to x bar. The y bar is already 0 millimeters. Okay. So 116.4 millimeters. All right. So this problem um, has been solved. Let's look at the last problem. All right. So let's look at the last problem in this tutorial set. So we have been asked to find again the x bar and the y bar of this figure. So we, of course, like we've been doing, how many areas? In fact, there are 3 areas. So picture the whole of this as though you have a semicircle and you have taken a triangle away, and then you have also taken a square or a rectangle away. So we are going to take the whole of this as though one complete semicircle. Then this is a triangle taken away from it. Then I have, a square taken away from it. So let's start the analysis from the semicircle. So for the semicircle, we will calculate x bar and then y bar. But let's look at something here. You can clearly see that over here, the y-axis is dividing the semicircle exactly into 2. Now what happens is that whenever the x-axis or the y-axis, whichever of them, divides an area into 2 like this. So for instance, for this one, since the y-axis is dividing the area into 2, then we say that the first moment of area about this area is going to be 0. But the first moment of area about the y is x bar a. So what happens is that if the first moment of area is 0, then the x bar is also 0. So for this problem, all the x bar will be 0. Okay, all the x bar will be 0 because It actually divides the whole of this into two equal halves. All right. So the x bar is 0 for the semicircle anyway. All right. Um all right. So like I said, x bar is 0. Okay. Now let's find y bar. Interestingly, there is a certain formula which states that whenever I have a semicircle, then the centroid of the semicircle. So for instance, let's say I have a semicircle over here, then the centroid is located at a distance from the base, which is given by 4 multiplied by the radius to 4r over 3 pi. So if I consider this whole big semicircle, it's going to be 4. So in other words, we are looking at a distant centroid somewhere, not necessarily at the 75, but somewhere here. And we are saying that that distance is given by 4r divided by 3 pi. It's going to be 4 multiplied by the radius. The radius is what? 125 divided by 3 pi, which is 3. Okay, so 3 pi. So what then is our y bar? 4 multiplied by 125. 4 multiplied by 125 divided by 3 pi. So 53.05. Our y bar is 53.05 millimeters. Okay, now for the triangle, again the x bar is so for the triangle, again the x bar. So when I say the x bar of the triangle, this is the origin, right? So this is not 0. Why is this not 0? Because if I have this triangle, okay, let's say this is a triangle. The axis does not divide it exactly into two. It is only the semicircle area which it divides into two. And that is the reason why the moment of area was 0. But the triangle is here. So please, it is not 0. But for the semicircle, it is 0. To calculate the x bar, it is given by a formula 1/3 from the height, 1/3 of the height from the base. So let's say that this is our base, okay? Then along the x, our x bar will be somewhere 1/3 from this distance. So if this distance is, let's say, 75, then our centroid is somewhere here, and then we are saying that distance from origin to here, or from the base, is going to be 1/3. Now don't forget that it's actually in the negative area, so 1/3 of 75, which is what? So 1/3 of 75, which is 25. So minus 25 millimeters. And that is to say that the centroid of the triangle is located at the distance along the x at a distance of minus 25. How about the y? So the y bar is like saying that you want to start from the origin and locate the center. Now, interestingly, if I take the horizontal side as the base now, then the center coordinate, so the center coordinate will be somewhere, let's say along the y. If the whole of this distance is 75, then the centroid will be at a distance 1/3 of 75 from the base. So in other words, the centroid along the y is a distance 25. Again, don't forget that 1/3 of 75 is what? 25 millimeters. Okay, so I have my S bar and my Y bar. Let's calculate the area of the triangle going to 1/2 base times height. And what is that? So that is going to be 1/2 multiplied by the base multiplied by the height. But you know what? We are going to get 2812.5. So 2812.5 millimeters squared, but we will negate it. Why are we going to negate it? Because we are going to assume that it is like the whole of this is actually a semicircle, and then I have taken a portion away. So that portion that I have taken away is like a form of a negative area. So again, the area of the square will also be negated. All right. It's like you have taken something away. Let me clarify this. The x bar was negative because this is the origin. So if I go in this direction, then it is going to be negative. Okay. So that's why the x bar was negative. All right. So we are done with the triangle. Let's look at the square or the rectangle. So looking at the square, or in other words, the rectangle, so the semicircle was 1, the triangle was 2, and now the rectangle is 3. Let's look at the x bar of the rectangle. So the x bar of the rectangle is like starting from the origin and walking halfway till you get to the center of the rectangle. And that distance is going to be halfway of what? 75, isn't it? And then again, if I want the y bar, that is going to be in the vertical direction, halfway of 75. So for this one, it's going to be simple. The x bar and the y bar will all be what? Halfway of 75. Again, halfway of 75. So that is 1/2 of 75, and that is going to give us what? So 1/2 of 75, which is what? 37.5 millimeters. Again, so since I'm not going to go in the negative x or negative y, for the rectangle, everything is going to be positive. Again, the y bar is going to be 1/2 of 75, which is what? 37.5 millimeters. So for the rectangle, the x bar is what? 37.5 millimeters. Again, the y bar is what? Also 37.5 millimeters. All right. So now I hope the concept is clear. Um, let's find the area. So the area of this rectangle is what? 75. So 75 multiplied by what? 75, isn't it? And that is what? So 75 multiplied by 75, and that's going to be, so 75 multiplied by 75, 5625. So the area is 5625 millimeter squared. All right. So at this juncture, I think we are good to go. Um, we have x bar, y bar, and area for all of the figures. Now let me stress on this again. Whenever the x bar, whenever the y-axis or the x-axis, for instance, this one, the y-axis divide the area exactly into two, then that area will have the first moment of area about that axis is 0. All right. Again, let me say that it's very important to know this theorem. Whenever the axis passes through an area and divide it into two, then the first moment of area about that axis is 0. Okay. So because the semicircle is here and the y-axis is dividing the semicircle exactly into two, that is the reason why the x bar was 0. But if the whole area, including the square and the triangle, were all divided exactly into two by the y, then for that matter, the x bar would have been 0 for all of them. Please understand this theorem. Other than that, you get it wrong. Okay. So now I want us to put everything we have into a table. Let's quickly do that. All right. So there we are with our table. We are going to complete this table by the areas given to us. So starting from the first area, we will look at the semicircle. Uh, oh, we didn't calculate the area of the semicircle. Wow. So the area of the semicircle is actually going to be one half the area of a circle, which is one half pi into r squared, which is 125 squared. And that is going to give us, so one half multiplied by pi multiplied by 125 squared. Okay, so 24543, so 24543.69 millimeters squared. All right, so for this one, it must be noted that okay, let's just go and add it there. So the area of the semicircle, please, this is not negated. That's what I wanted to say. This area is not negated because it's actually the actual area occupied by the semicircle. So it is not going to be negated. So it's going to be 24543. So 24543.69. All right. The x bar is 0 because the y-axis is passive string. Therefore, the percent of area about the y-axis is 0. However, the y-bar is not 0. In fact, the y-bar is actually 53.05 millimeters. So 53.05. Okay. Now, with regard to the second area, which is the triangle, the area is actually a whole. So it's like an area, a portion which has been taken outside the actual area. And so for the triangle, the area is what? Minus 2812.5. So minus 2812.5. Is that right? All right. Then the S bar, so the S bar is minus 25, but the Y bar is 25. Okay. So minus 25 and then 25. Minus 25 and then 25. Oh, sorry. The Y bar is actually 25. Finally, with the rectangle, let's not forget that the rectangle is also a whole. So we would have to negate the area of the rectangle. So the S bar is, okay, so minus 56.25, 37.5, again 37.5. All right. So please, let's not forget this. The rectangle is a whole. So it is negated, and then the triangle is also negated. I think we have done that. Okay. So having done this, then it means we are good to go. So we would have to just look at the columns. So let's look at this column AI S bar I. It means that I will multiply each area with the S bar. But interestingly for us, for this side, it's going to be 0. So let me do the other side, which is the next column. So minus 2812.5, and I'll multiply it by minus 25. If I do this, I'm going to get positive 70 312.5. 70312.5. Again, if I have this one, it's going to be minus 5625 multiplied by 37.5. And that is going to be what? Minus 210937. So 210937.5. Is that right? Okay. So at this juncture, we would have to do AI y bar I. Let's do that together. So doing AI y bar I is going to be 24543.69 multiplied by 53.05. I do this, wow, 1302042, 1302042 point what? 755. Okay, so that part is gone. Then we will come to the second part, minus 2812.5, and then I'll multiply it by 25. So it will be minus, so it will be the same thing as the AIS by I, but it's going to be negated. And finally, I'm going to do this. I think this one will also be the same because the X bar and the Y bar is the same. So it's going to also be minus 210937.5. At this juncture, I want us to do summation AI. So we are going to add the areas. It's going to be 24543.69 minus 2812.5 minus 5625, right? So basically 2453.69 minus 2812.5 minus 5625, right? And that is 16106.19. 16106.19, okay. Millimeter squared. Then I have summation AI S bar I. What is it going to be? So 70312.5 minus 210937.5. That is what? Minus 140625. Minus 140625. Again, so with respect to the summation AI y bar I, so that one is going to be what? So 1302042.755 minus 70312.5 minus 210937.5, and that will give us 1020792. 1020792. 1020792.755. Okay, so millimeters cube, and this one is also in millimeters cube. At this juncture, we are good to go. We just have to divide. So to get x bar, then it's going to be summation AI x bar I divided by summation AI, which is what? Minus 140625 all divided by 16106.19. And then the y bar is going to be summation AI y bar I divided by summation AI. And what is that? In fact, that is going to be 1020792.755 all divided by 161 um, 16106.19. Now, if I do this, it's going to be for the S bar. So for the S bar, I'm going to calculate the S bar and I will get um, minus 140,625 divided by 16106.19. So minus 140,625 divided by 16106.19. We need to make sure that all the values we are getting is correct. So that's why I'm taking my time to do that. So the S bar is going to be minus 8.73. So minus 8.73 millimeters. All right. And then for the Y bar, I'm going to get that is 1020792.755 divided by 16106.19, and that is 63.378. So let's say 63 point, yeah, 63.38. Okay, 63.38 millimeters. Now, intuitively, what this means is that if I want to locate the actual centroid of this, then it is somewhere along the x in this direction, which is 8.73. So let's say somewhere here. And then along the y, it will come up vertically, and that is 63. So maybe somewhere here. So the along the x, it is what? 8.73 in the negative x direction. And then along the y, it is what? 63.38, right? 63.38 millimeters. All right, so this problem has been solved. That is the end of the tutorial. Thank you very much for watching. I hope you have learned something new. Kindly like the video, share it to your friends, and subscribe. If you have a problem or challenge after watching the video, please leave it in the comment section. Thank you very much for watching.